entitle your notes Solids of Rotation. Solids of rotation. Okay? What is a solid of rotation, you may ask? Well, watch this. Let me pause this here and get a picture of this. Okay, so let's just dive into the examples. A solid of rotation, we're gonna draw it together, and as we draw it, I'm gonna talk about the parts of it. So right now, go ahead and write example 1. Go ahead and draw a line, and notice there's a square we have this line right here, and you have a square that's kind of attached to the line, right? Go ahead and draw that. Okay, so what I'm going to do now is it's kind of like a funny example. I have a little post-it note in my hand. The post-it note is kind of like symbolizing the square you just drew, a 6x6 square. Okay? And then let me get my pen here. My pen is kind of symbolizing the axis there, or that line that the square is attached to. Let me do this here. So what I have in my hand is kind of what you drew. Notice that, all you in Zoom land. Okay? So there's a line and then there's a square. Now imagine, if you would, well, you don't have to imagine, I'm actually going to do it in front of you. Watch this. There's no imagination involved here. I'm going to do it. Watch what I do with my pen. Okay? What I'm going to do, imagine me taking this two-dimensional, remember that this paper is 2 dimensions. It's only got length and width. It's completely flat. But imagine if I did this. If I started rotating it. Imagine me rotating it through space. What kind of shape, what kind of 3-dimensional shape am I forming if I kept rotating this? Look at it like this. You could kind of see a 3-dimensional shape being formed as I rotate this 2-dimensional square. Can anybody tell me what's being formed? What 3-dimensional shape? What's solid? I'll draw it for us. Watch. As I spin this around, right? I was spinning it around this way. What was being formed was a cylinder, right? Let me show you. A cylinder was being formed. As I spin along its axis. So when I spin this 2-dimensional square, a cylinder is actually being formed. So we call that a solid of rotation. That's it. So if I asked, okay, well, before I even do that, let me show you a little video here. Watch these solids of rotation being filmed here. Look at this. So look at these solids of rotation here. They're spinned along an axis here. Notice notice the axis, okay? There's a cone, there's a cylinder, a truncated cone, and a sphere. Notice all these, look at, there's a shape. And now you're going to spin them along an axis. Notice that. See how they're rotating? They form the solid. So you can see that the cylinder is formed by a rectangle being rotated along an axis. The sphere is formed by a half circle being rotated around the axis. The truncated cone is kind of like a trapezoid. So the truncated cone, that's kind of interesting. It's actually a trapezoid being rotated along an axis. And then a cone is a triangle being rotated around an axis. So that's like the big idea of solids of rotation is you have two-dimensional figures being rotated along, watch this now, by the way, did you guys just see that video in Zoomland? Ramos? Morales, you guys see that video or no? Did that show?
I'm not sure.
Here. I hope I showed that. So look at these solids of rotation here.
Yeah, I can see it.
Okay, so watch this. So notice the cylinder is a rectangle being rotated around an axis. A cone is a triangle. A truncated cone is a trapezoid being rotated, and a sphere is half a circle being rotated. Okay? These are called solids of rotation because you're rotating a two-dimensional shape, 2D, around an axis, and it creates a three-dimensional solid. Now when I say solid, remember I'm talking about three-dimensional figure. Okay, so here we go. So on your notes, we're almost done already. On your notes, this is called right here, that line, which is like my pen in my hand, we call that the axis of rotation. There's your calculus concept. Axis of rotation. You'll hear about this when you get to calculus. The axis of rotation. Okay, so far so good. So let's find the volume. Find the volume of the cylinder. So this would be a cylinder. I'm going to draw the cylinder that's formed. Right? It would have a radius of 6, a height of 6. So if I spin this around, I'm creating this. I'm creating a cylinder with a radius of 6. Nice. Here we go. Let me sip my coffee. All right. Let's find the volume of a cylinder. So that comes from our formula table. The volume of a cylinder is the area of the base times the height. We did that, I think, 2 weeks ago. So the area of the base, well, that's the area of either the top or bottom circle. That's the area. So let's find the area of this base. What are the square units of that base? Well, that's the area of a circle. So I'm going to replace b with pi r squared. That's the area of a circle. And then I'm going to replace height with 6. Look at, here's the height of the cylinder, is 6. So far so good. So I'm going to approximate. So I'm going to replace pi with 3.14. So we've got 3.14 times 6 squared times 6, because the radius is 6. Okay. So let me get my calculator out here. Here we go. I got 3.14 times 6. Actually, no, it's going to be 36 now. I got to do the exponent first. So this is 3.14. I got to be careful here. 3.14. I got to do the 6 to the second power first, times 36 times 6. So here we go. 3.14 times 36 times 6. The volume then is 678.24. Now, they didn't specify here, huh? Gosh. They didn't specify if this was 6 inches, 6 feet, 6 yards. So we're just going to write the generic word units, because they didn't specify what's being counted. So this would be cubic units. Cubic units, because we're dealing with volume. Done. Let's try number 2. So look at number 2. Look what we got. Here's my axis of rotation. Here's my, I'll put an AOR, axis of rotation. So we're going to spin that around the axis, right? We're spinning it around this way, around and around. You can see that this is going to be formed, watch. It's going to be half a sphere. Do you not see that? I got this going on because I'm spinning it around that axis of rotation, right? So we're going to have a half a sphere with a radius now. Watch this. The radius is going to be 9. 9 units. Okay. So we're spinning it around the axis of rotation. Okay. And we end up with a half a sphere. So let's find the volume of a half a sphere. Okay, so the volume formula for a sphere is 4/3 pi r cubed. Right? But in the end, we'll just chop it in half. We'll take it and divide it by 2. So we're going to pretend the whole sphere is here for now, and then in the end, I'll just divide by 2 because we only have half a sphere. So we did this for warm-up, no big deal. So the volume then is approximately 4/3 times 3.14 times the radius is 9 to the 3rd power. I'm going to put this all over 1 because I'm going to multiply by fractions right now. So far, so good. All right. So, volume then is approximately 4 times 3.14. 9 to the 3rd power, I forget, I don't know, let's see, 9 times 9 times 9, 729 over 3. So far, so good. So what I'm going to do now is I'm going to multiply all the numerator out. So 4 times, let's see, 4 times 3.14 times 729. I get 9,156.24 divided by 3 now. Let me divide that by 3. So the volume then, if the whole sphere was there, the volume would be 3,052.08 cubic units. But the whole sphere is not there. I'm dealing with half a sphere, right? This is only half a sphere up here. So I'm going to take this volume, which is assuming the whole sphere is there. I'm going to divide that puppy by 2. So the volume of that half sphere then is going to be 1,526.04 cubic units. Awesome, awesome, awesome. So,